Why do you think only a third of the class shows up? And you're not the ones to ask, you're here, right? Whatever. So with text files, we saw reading in text files. And remember, when I was saying text file, I mean text. I don't mean like a document file. I don't mean like a Word file that's got text in it. I mean like an actual text file where all that's there is just basic text. And that's great for a general purpose data, right? Just some text. You might need some parsing. Another really common format is a CSV. And CSV, or comma-separated values, is good for if you have like tabular data, data that can be represented in a table. Now, you will see some people, instead of using, well, here, let me explain. So, for example, if here is some data that was in a CSV, this would be data that you would see in a CSV. And not every CSV file will have like a header row, like that one there, name, height, weight, IQ. But this is a CSV kind of representing a table, or no, it is representing a table of data that has 4 columns and 4 rows. The first row being like a header row. Not all CSV files have a header like that, and that's fine. You just have to know what it is. Each comma separates the data between rows, and each new line is a new row. That's it. So if we were to take this CSV and think of it as if it was in a table, it would look like this. All right? CSVs are great if you have tabular data, data that should be represented in a table. It doesn't have to be numbers. It could be strings, numbers, floats, booleans, whatever. But if it's in a table, we like to store it as a CSV. Sometimes you will see people use other characters as delimiters, as things to like separate the columns. Don't be like those people. Use commas because it's called CSV, because it's comma separated. So use commas. There might be a funny, peculiar case where you just can't, but in general, you're going to want to use commas. And what's nice about a CSV is, did anyone open? So on assignment 1, there was a CSV that you used, the Starbucks location. Did anyone like open that file separately? And what did it open in? I'm hearing a lot of, speak up. Like Excel, yeah. Was this you trying to remember the name of Excel, you know, with like the rows and the, yeah, it's Excel. Now, it's not an Excel file. You can't do like the math. I mean, you can do the math in Excel on a CSV, but if you go to save that file, it won't save like the math and all the Excel fancy stuff. It's just a CSV. But what's neat is, yeah, it'll even open it up. Your computer will happily open it up. Excel will happily open up CSV files because it's nice to look at the data kind of in like more explicit a table, right? If we go back and look at assignment 1, this is what you see. Now, I could have used I could have opened up this CSV file as a regular old file and read it that way. Easy peasy. But there's also a library called CSV that makes it even a little easier to load up a CSV file. Just a little bit easier, which is nice. And what's nice about this thing is it actually manages like the, well, here we actually explicitly close it, but the CSV reader will actually manage the opening and closing of a file, a CSV writer at least. So here we go, we import CSV, we open the file, and then we give that file to a csv.reader. I create an empty list of Starbucks locations, and then for each row in the Starbucks file reader. So this will be a row, but the row itself will actually just be a list. A list being each of the values in the row separated by commas, which is really nice. Now here I actually just basically took the list and converted it to a tuple, whatever. But that's all I did here. So this is an example of loading up a CSV. So here's an activity here. First, I'm going to do the first one together. I'm going to download the CSV file. Here, I'm going to upload airport CSV. Yeah. And first of all, what's actually kind of neat here, I opened up the CSV file. And if I open up the CSV file in Colab, it'll even like load it as a table. And it's even smart enough to know that the first row in that CSV file is a header row, so it's kind of like separated a little differently, which is nice. This file does not contain a table. It doesn't. It's just Colab is rendering the data in it as if it was a table. The file, all it really contains is commas, data with commas between them. And let me show you. So if I were to just open it, my computer wants to open it with Excel. But if I open it, it's just string, comma, string. String, comma, another string. String, comma, another string, and so on. So this is like a table with 2 columns and how many rows? $157 rows. Cool. So let's just close this. Now, write a function called write a function called load airports that loads the CSV file into a list and returns the list. So write a function, def load airports, I'll put a file name in here. Write a function that will load up that file, load up that data, and return a list. I'll give you a few moments to work on this one. And as a point of reference, use the load Starbucks data right here. Use this as your reference for loading up the airports file. Make sure in order to load it, you need to upload it to Colab. So take a few moments to try this one. Raise your hand if you're done. Raise your hand if you'll be done in a minute. Cool. So here's my solution. I imported CSV, and I guess I didn't really need to do that inside the function. I could have put that outside the function, whatever. Here, I actually just combined this to one line of code. I made a CSV reader, but I immediately just passed the file to the CSV reader. Didn't need to actually make a separate variable just because I'm lazy. Create an empty airports list for each row in airports. Airports.append the row. Because remember, each row will actually be a list already. And then at the end, anyone want to take a wild guess? It's no mystery. It's just you might not have realized why. Anyone want to take a wild guess why I actually did a slice of the list at the end to return? Yeah. Just because I just didn't care about that first row. The first row is just a header, so I did that. I could have included it. Doesn't really matter. If I run it and then run it, there. Now it includes airport code and airport, right? But here, don't really need it. One to the end. Great. Run. Cool. Did anyone do it any vastly differently? I'm actually going to show you something kind of neat here. With a CSV, you actually can get away with doing this. There. You could just wrap it all in like list, and it's smart enough to go, okay, just turn it into a list of the lists. Great. Which is kind of nice. Now, I didn't do that on assignment 1 because I think that would just freak everybody out. I think the way it was written out in assignment 1 was a little easier to follow, a little easier to understand, but you could do it this way. Now, imagine for a second now with this, I'm telling you, write a function that, given the list of airports and given the airport code, return the name of the airport. All right? So, sounds like a linear search to me, right? Okay, for in list of airports, airport list. Now remember, airport list is a list of references to lists, right? The thing that airport is going to be a list that contains the airport code at index 0 and then the airport name at index 1, right? So if I want to check if if airport code is equal to airport at index 0, right? So if I said ABE, it would go, this is the first airport, and then the airport at index 0 is ABE. If that's ABE, what should I return? Well, I should return and like return -1 if it's not found. That linear search, any big questions about it? Shouldn't be too much for you. Maybe the only thing throwing you off is the fact that we have to, the thing that we're looping over is a list. But it's just a linear search. Any questions about that? So, if I were to say, what was it called? Get name from code. And if we say YYZ in airports, great, cool. I have no idea if that's 1. No, -1. There. All right, it seems to be working just fine. And of course, this is making use of a linear search, meaning I have a list of airports. And if I want to find an airport, how many do I have to look at to guarantee I find what I'm looking for? All of them, yeah, right? I mean, this list of airports, maybe it was sorted alphabetically, I don't know. But it's seeming maybe it wasn't, and if that's the case, if I want to find a given airport, I have to look at each thing. And if I find it, great. If I don't, keep going. And the only way I know if something's not there, like I just looked for like, I don't know, let's try ABF. There is no ABF. So if I wanted to find, how many did I have to look at? All of them, in order to conclude that ABF wasn't there. Well, actually, let's take a moment and let's have a quick little aside here. If I gave you a sorted list of things, would that change how you search through it? Think about that for a second. What would you do differently? If I gave you a phone book, but it wasn't sorted in any way. You know what a phone book is, right? You're laughing, but a couple of people just are still looking at me with a blank face. Raise your hand if you don't know what a phone book is. Okay, so everyone knows what it is then. All right, fine. Imagine it wasn't ordered, and I told you find so-and-so in there. And that phone book probably has like tens of thousands of names in it, right? And if you look at the first one, and it's not what you're looking for, you have to look at, let's say there's 20,000 names in there. You've eliminated one from your search. I still have 19,999 to go. You look at another one, you eliminate one for your search. 19,998, right? But a phone book is sorted. So if you went to look up something in a phone book, do you start at the beginning and just start flipping? No, what do you do? Yeah, well, let's assume it's just sorted alphabetically. What do? You go to the letter. Yeah, but how? You just open it to the letter? No. Let's say you're looking for someone whose last name starts with M. And you open it up and you happen to get to D. Right? So I'm looking at the page that says D. M is clearly on this side because M comes after D, right? But I've got all the letters like A through D on this side. Do I care about those anymore? With a linear search, every time I looked at one thing, I eliminated one thing. But you eliminated a hell of a lot more than one thing at a time there, didn't you? Yeah. If I told you, if I said open your textbook to page 500, and you open the book to page 400, and let's say there's 600 pages in the book, you know which side to keep looking, right? You don't bother looking at 0 or 1 through 400. That's silly. You're not going to find 500 over there. Kind of crazy, right? Yeah. Anyways, we'll come back to that a little later. Now this right here, a linear search. Does anyone have any comments about this linear search? Questions, thoughts, concerns? Really? Because this is a terrible idea. Why would I ever want to do a linear search on something like this? What else could I do? Put it in a dictionary, yeah. Airport codes are unique. And looking something up in a dictionary is constant time. It's always like that, a couple asterisks. If I have 100 airports, I have to look at 100 with a linear search. If I have 1,000, I have to look at 1,000. With a dictionary, it's one lookup. So I could actually put this in a dictionary. And let me go back here. Oh, no. That was fine. Here, what's actually kind of nice is just because the data, that probably isn't going to work. Just because the data it's a list of lists that are too big, Python's happy to convert it to a dictionary. It'll assume index 0 of the inner list is the key and index 1 is the value. If it's not, well, do what you got to do. But with that, I don't even need. I could just say YYZ. And it tells me. So that actually eliminates the need for linear search, which is great. We want that. All right. And you can also write to a CSV file pretty easily. But instead of a CSV.reader, we use a CSV.writer. And it needs a file that's writable. And if you have a list of lists, you can just write to a CSV file. It's smart enough to know, okay, each list is a row and each value on the inner lists are the columns. Or you can write individual rows at a time by saying write row, and it takes a list. And it basically writes, okay, first cell, it adds a comma, second cell adds a comma between each thing, which is great. CSV files. So a general text file is a general text file. It's great for storing any arbitrary data. A CSV file is more specialized. It's not as general as it's just a basic text file, but because of it, we can make a couple assumptions about the data, and it makes it a little easier to work with. So if you ever have data that's like tabular, which if you're doing any like analysis on data, like any data science or anything, your data is going to be tabular. It's going to be like representable in a table. CSV files, we love CSV files. They're fantastic. Any questions about CSV files? Is that your hand up or just a scratch? Scratch. All right, exceptions. We've all seen exceptions at this point. They're the things that pop up in Python that would be like, okay, value error. Whenever your program crashes and you see something error. That's what we call an exception. But one thing that's important to note about exceptions is they're not necessarily errors. They might be, but they're not necessarily an error. An exception, really what that is a message. It's a piece of information for you, the programmer, to deal with accordingly. For now, we haven't really been dealing with the exceptions. When we get an exception and it crashes our program, that's how we've been dealing with it. We ignore them, and mostly because the exceptions we've been getting at this stage are a consequence of an error. But exceptions are a little bit more than that. They're a little bit more special. This whole topic, like, I'm not going to have a chunk of the exam on exceptions or anything. That's not the point of this topic right now. The point of this topic is to make you aware of exceptions and what they are. Because they're very important and they're going to keep popping up if you keep programming. So in the above example there on the hello, the computer was saying, I can't convert the string hello to an integer. Which is pretty obvious, right? Like, how would you do that? So when I asked the computer, if I were to write that line of code, convert hello to an int, it's going to give me this exception back, value error. Can't convert hello into a base 10 integer. Can't do it. Then you're faced with a question you have to ask yourself. Okay, I asked Python, I asked a chunk of code to do something. And it didn't do what I asked it to do, did it? No. It gave me back an exception. And it said, I can't do that. So now you're faced with this question of, what are you going to do about that? And that's a decision you have to make. Up until now, the thing we've been doing about it has been, all right, try to fix it, something went wrong, right? Because it was, chances are it was an error. Here's another one. Index error. List index out of range. I can't do it. You can't, the computer's saying, I can't do this for you because there is no index there. There is no value at that index. So how am I supposed to deal with this? Now, index errors are often caused by the programmer's issues there. This value error, this index error, those are just two of many different types of errors. There's a lot of different errors that could pop up, and they're all exceptions. In other programming language, they will specify the difference between an error and an exception, but in Python, they all just come up as errors. Doesn't really matter. Even though it's not necessarily an error, it could just be an exception. And the reason I'm calling it an exception is the exception might be an error, but an exception really is more of some exceptional situation happened. The normal operation of saying int on some string is you give it an integer, a string that contains an integer, and it converts it to that. You ask a function to do that, that's what it does. That's its normal operating behavior. But then finally you give it something it can't. That's an exceptional situation. Something funny happened there. Maybe it was by accident. Maybe it was on purpose. I don't know. If I'm the one, so someone at some point in time wrote the code to convert strings to integers. Realize that. Someone wrote that code. And maybe they wrote that code in 1989. All right? So the person who wrote that code in 1989, they're like, okay, if they give me a string, convert it to an integer, I'm going to code it all up. And then they had to sit there and they thought to themselves a second, what do I do if someone, because they wrote that function, what do I do if someone gives me an argument that I can't convert to an integer? What do I do about that? Should I crash the program? Should I ignore it? Should I tell them to try again? Should I assign some special value? Should I return none? I don't know. What do I do about that? And we can't answer that question because the person who wrote that code back in 1989 has no idea what you today in 2023 want to do. You're the one that called my code. And something funny happened. So I don't know what I should do in your situation more than 30 years in the future. All I can do is let you know by giving you an exception that says, I can't do this. Then it's up to you to decide what you want to do about it. Do you want to ignore it? Do you want to crash the program? Do you want to assign some special value? I don't know. It's up to you. It's not up to the person in 1989 writing that code. All they are going to do is give you a special value, a special thing called the exception that informs you that something funny happened so you can make a decision today on what you want to do about it. I'll give you a concrete example to work through. Imagine this function here. I'm writing this code. It's 1991 and I'm writing this code. Divide. Obviously, I know divide already exists, but let's pretend it's 1991 and I'm writing this function. Divide has A, B, but the problem is, if you give me a denominator that's 0, I can't do that. I can't divide by 0. I can't. Every other case, I'll just do the division. But in the very special case that B is 0, we're going to raise this exception. Because if you're using my code in 2023, I'm writing this in 91. If you're using my code in 2023 and you give it 0 as the denominator, what do you want to do about it? Was that just the programmer accidentally put in a 0? Or was data read from a sensor and the sensor gave a 0 to this function? And what is your program doing? Is your program monitoring plants? Or is it keeping a helicopter in the sky? Is it doing a calculation to determine how much radiation therapy to give to somebody? Depending on what your program is doing will dictate what the hell you want to do about this situation. If you're writing code to calculate how much radiation to give to somebody, and you tried to divide by 0 for whatever reason, I probably want the program to stop running immediately. I don't want it to do a poor calculation on the amount of radiation to give somebody, because that might literally kill them. So I probably, if that happens, I want the program to crash and stop running immediately. Or maybe it's keeping a helicopter in the sky. Maybe your program is reading from some sensors and it's keeping a helicopter in the sky. And the last thing I want to happen is if a sensor returns 0 for whatever reason, the last thing I want is for the program to stop running. I don't want my helicopter to crash. It all depends. What we, the programmer today, using code written more than 30 years ago, what we want to do with these exceptional situations all depends on what we want to do in the exceptional situation. If you're thinking, how am I supposed to know what to do? The answer is, ask yourself, what should you do? Do you really want your helicopter to stop running its program, keeping it in the sky? Probably not. So yeah, maybe you kind of deal with it in a way, that way accordingly. If it's calculating the amount of radiation therapy, probably don't want to ignore the issue and divide by some arbitrarily small number to give you a huge value of radiation to just kill the person. Probably don't want to do that. So it all depends on the situation. So this is how the programmer in 1991 writes their code. They say, okay, if we just so happen to get that exceptional situation, I'm going to use this keyword raise, and conveniently there is a well-named error already existing in Python called a zero division error. There's not always a named exception for the problem you're going to run into. They actually have like a hierarchy. Chances are if you don't have it, there's going to be something called like a runtime error where just some arbitrary thing went wrong. But because there's a zero division error, I'm going to use it. If the funny thing happens, you raise this exception. When that happens, this function never returns a value. It kind of like returns an exception instead. It doesn't return a float, which is the division. It returns kind of this exception. It immediately stops executing normally, and it just raises this exception. That's what the programmer in 1991 does. And if B is not 0, it just operates normally. For every other condition, for every other value of B, just do the division. But if you just so happen to give me a 0 for the denominator, raise this exception. So that's how I could write this code. This is how I communicate to the person using my function that if they gave me a B of 0, a denominator of 0, something weird happened. You can't do that. I can't divide by 0. What do you want to do about that? So that's how the programmer in 1991 deals with it. You today, the person using the code from the past, deals with it in a different way by catching the exception and writing the code that says what you want to do about that exceptional situation after you catch it. And here is a generalized view of how you would write it. So I've got some arbitrary function. It doesn't need to be inside a function either. It's just some arbitrary code. And I would say try. Try this block of code that I know might raise an exception. Right? If that code runs and no exception is raised, all of the code in that try block runs normally. And if no exception was raised, it skips everything in that exception block and carries on afterwards normally. Just kind of like an if statement, right? Think of the except some error as an if. If the exception was thrown, you do this. Otherwise, you ignore it. That's how you could think about it. But let's get a more specific example. Maybe for our purposes, what we'll do is there is a special value for a float called nan, not a number, an an. It's a float, but it doesn't actually have like a numerical value associated with it. It's a special value that can exist for floating point numbers. And it's kind of a great use of this nan value would be in this particular situation. You know, if you tried to divide by 0 on your calculator, it probably like says undefined or something, right? So what we can do here is just return a value. We could still return a value. In fact, we could still return a float. But that float, its value will just be not a number. So here's what I can do. Today, I'm using this division, and for whatever reason, it's important that that function, I still get back a number. Sorry, I still get back a float. But I can't just ignore the fact that the exception's raised. No, I still have to manage the exception because the programmer in 1991 was responsible. They said, I need to let them know something funny can happen. And if something funny happens, they have to deal with it. I've done my due diligence. I've informed them in the future that something funny happened. It's up to them to deal with it. So the programmer today says, okay, I'm going to try to do that division. If the division happened normally, if b wasn't 0, quotient gets assigned its proper value. We skip lines 4 and 5, and we just return the quotient. If, however, b is 0, and that code says, nope, nope, I'm not returning any quotient value, I'm going to raise this exception. My code today then says, okay, I'm going to accept that 0 division error, and when that happens, I'm going to assign to the quotient not a number, that special value. It's still a float, but it doesn't actually have a value really associated, like a numerical value associated with it. So I'll just return that instead. So this is like a wrapper function that will handle the exception and just modify what gets returned accordingly, based on my needs. If you're wondering, but how is that different than raising the exception? It's remarkably different, because if you didn't handle the exception, what happens if you don't manage an exception and you hit run on your code and the exception gets thrown? What happens to your program? It stops. So this would prevent your program from stopping, and it would just carry on running, but it returned this special value. Here's another one. Maybe you're asking for input. It's a program that's going to prompt the user for 2 numbers, and it's going to do the division. But if the user accidentally enters a 0, just have them try again. So if we look at this code, on line 2, I actually create an infinite loop while true. I read the input, I parse the input, I try to do the division. If the division comes back on line, what line is that, 6? No, line 7. If the division runs and no exception was thrown, then we break. Who knows what break does? 2 people? It's just a keyword that means stop the loop you're in. Stop the immediate loop that you're in. If you have a loop in a loop and there's a break, it'll only break you out of the lowest level one. But that ends the loop. Anything you do with the break, you could rewrite this code such that you didn't need a break and you could just change the condition. But this was the easiest way, in my opinion. What's up? Depends on who you ask. Some programmers will be like, never use breaks. They're bad. And they'll often cite, I think Dijkstra? Maybe not Dijkstra. Could be another famous computer scientist. But they'll often cite a famous computer scientist who says, they say like, oh, it's basically like a goto, and gotos are bad. And then they'll cite the famous computer scientist because they say gotos are bad. I won't get into details of what all that means. But that famous scientist that they're referring to has, unless it's a condition where it's something like a break. So they'll often cite someone who explicitly said that this is okay as evidence that this is not okay. In my opinion, if it's quick and dirty code, a break is fine. If I'm like, no, I want to make good code that I want to exist and maybe needs to be maintained a little better, I would rewrite it a little bit. But for this purposes, it's fine. If it's easy to avoid the break, avoid the break. If it's a pain in the ass and this does the trick, it's fine. There are some programmers, though, that are like aggressively against like break statements. They're fine. There's another similar one that's called continue. There's a keyword called continue so a loop will run. The condition's true. It runs all the code in the loop, all 50 lines of code in the loop, for example, and then it starts again until the condition's not true. A break, if there's like an if and a break, it stops and carries on after the loop. A continue, on the other hand, will run all the code, but maybe it hits a continue about halfway through executing that loop. And instead of finishing that, the rest of it to go back to the top, the continue will stop that current iteration and go back to the top of the loop and start again. They do have their own unique special use cases where they'll come up, but you don't need them. Some people like them, some people hate them. But this is an example that says, now remember, if divide, note, if divide raises an exception, all of the code below it in the try block is skipped. It immediately goes down to the 0 division error. So if I entered a 0, it skips the break. It goes here and it says, can't do that. It finishes the except, goes back to the top of the loop, and it prompts them again for input. This will continue to prompt them for input until they enter correct input. Because as soon as the division actually works, we break. There. So this is, if my code today, they entered their input wrong, just have them enter it again. Keep asking, keep trying until it works. There. The first way we dealt with the situation of the divide by 0 was just assign that special not a number value. Now it's, well, no, just keep prompting them for input until it works. That's a different way to handle that exceptional situation. And here's another one, is we can call exit. Exit is a keyword or is a function that stops Python. It'll shut the program down. You don't even actually need to say exit, because what happens if you don't handle the exception? It stops the program anyways. Perhaps this is a little cleaner, fine. Or maybe it just so happens that it doesn't matter. We'll just ignore the situation. Who here's seen that keyword there, pass? It's a keyword that just means nothing. If you ever have a line of code in Python that has like an indent block, for example, like def and let's say I want to write this function, but you know what? I don't really want to write it right now. I'll just come back to it later and then like print 1. And I try to run this. It's going to say, well, no, I need to have something indented here. Well, in this particular situation, I can say pass. And pass is a way to have something there that means nothing. So in this particular situation is try to do the division. If it doesn't work, just ignore it. It doesn't matter for my purposes. It's very different than return. It's not the same at all. What?
No, I was just wondering, would it be any different than return than just doing a pass?
Yes. I mean, there's no function here. You only have returns and functions, and return has a function. Return.
You could make that a function, no? Right? You could make that a function.
Sure. So I don't understand the question. So if I were to write this entirely differently, I could do it in a way where having a return here. But then what would I have outside of the except case? Another return? No, not really. It wouldn't do the same thing. It would act differently, yeah. Yeah, why care? Which of the above ways to deal with that situation was correct? Return a special value, keep asking, crash the program, ignore it? What was the correct thing to do? It depends on what you want to do. And so the programmer in 1991, they don't know what you want to do. All they can do is let you know that you have to do something about it. That's the whole point. Any last questions? Cool. All right, I'll catch y'all later. Remember, thoughts, concerns, questions, comments, you want to chat, come to student hours. I get lonely. I know there's no assignment due, so I'm going to be lonely.